Okay, f0 is a function that we use to find the zeros of a nonlinear function. Okay, for polynomials we use the root function, so here we can use f0 to find zeros of non-linear functions. Okay, so it has this form: x is the output value via the root, we store the root in x, f0 we give a function and a approximated root. Okay, this is something close to the root, approximated root. If we give a function and approximated root, f0 will find the solutions. So there are several ways to pass a function into this f0. The first method is to give the function as a string. Okay, we'll look at example. We'll try to solve this equation using f0. So first I have to convert this equation into standard form. Okay, so I convert this equation into standard form. So that is one side 0 minus a minus 0.2 equals 0. Okay, now if I find the zeros of this function, automatically I find the roots of equations. No, so for this I can use this function. For get the roots of this function, I need to plot this. First I find the approximated root. Okay, that I can do by plotting the function first. Okay, so let me log into MATLAB. Okay, so before calling f0, we need to draw an approximated plot. Okay, approximated plot, find the approximate root. So I will use linspace. We'll draw it between 0 and 8 and 0. Okay, whether we can find any. Yes, I'm going to draw the function between 0 and 8. I'll use 600 points. So here first I'm plotting the function to find the approximated root. Okay, now I need to give the function. Because this is in matrix form, I have to use star operator. So my function is dot. Here matrix, avoid the matrix multiplication, I want the element wise multiplication, so I use a dot here, minus x Okay, so this is my y. Okay, I have to use the other way around, sorry, dot first and then star. Okay, now I'll do a plotting. Now this is the y equals 0 1. I will do the grid on so we can see x-axis. Okay, so this is the x-axis. Closer to x-axis we can find two roots. Okay, so to find the one of roots I have to give a value close to that. Okay, so this is 1. It seems this value is close to something like point. If I try to get x equals 0.25, so I will use x equals 0.2 as approximated value. Okay, so for that I do f0 I have to give the function, so I said I am going to give it as a string, so this time I don't have to use the dot operation. Okay, p minus x 0.2 and close the string. My approximated value is 0.2. Okay, so I need to find the approximated root here. Okay, we will store this root in a variable. Is not required, but if I want to use it later you have to store it in a variable. x1, I'll remove the semicolon so we can see the solution. Okay, 2.2592. okay, so this is approximated root. Okay, so you can get a better approximation here by looking at the picture and starting with the approximated root. Okay, if I want to find the other root I need to give some value close to that. Okay, so let's say here this value x equals 0.47. okay, so if I give 0.47, okay, I use the semicolon, so sorry, this is not 0.47, something close to this root. What is a value close to this root? 2.68. okay, if I use the 0.47 still it's closer to the previous root, so it gives the previous root, so I will use a value close to this root. I can use either this side or any side, this doesn't matter. Okay, value close to, okay, we'll use this value 2.44. okay, so if I use, it can be further away, like you can see, I mean it can be little bit away, like 0.47 work, no? So I'll do 0.24. okay, as the approximated root. Okay, again I use the semicolon, so I'll do without. So other root is 2.542. okay, so here I pick a somewhat closer root. Even I use something like 2, it will work, okay, instead of 2.4 as the starting approximation. Use 2, it will take a little bit more time to find the root, but it finds the root, okay. So this approximated root is better than one you can approximate from this picture, okay, 2.55092. okay, so this way you can use the f-zeros function. So here I pick 0 and 8 as my starting domain for my graph. Most of the practical situations you will know the domain you are looking for roots, okay, so you can plot in that domain and see where the function cross the x-axis. One thing, this thing can find situations only where function crosses the x-axis, okay, that means situations like this, or this, or this, when the function crosses the x-axis, okay. If it just touch and go, then you cannot use this method. For example, if it comes like this and goes up again, you cannot use f-zero, okay. You can use f-zero only when function crossing the axis, okay. We'll talk about more about f-zeros and ways to give the functions to this command in next video.